Hello Python programmers. So this is the video 13th of our machine learning with Python video series, and in this video we're gonna talk about multiple linear regression. So this video is also divided into two sections. First is the theoretical part where we'll discuss that what is multiple linear regression. So for all those who haven't watched our previous video about simple linear regression, go watch that first, because in this video I'll just be differentiating between simple and multiple linear regression, because in that video I have explained very deeply that what is linear regression. So I'll use the same PPT and will just point out at the difference that is between the simple and multiple linear regression, because I don't want to waste time in explaining you all the things again and again. Okay, so watch that video first and then come back to this video to understand the theoretical part. And if you are here only to watch the programming of multiple linear regression, then you can skip to the programming part. Okay, so let's get started with the theory first. So this is the PPT that I have used to explain simple linear regression. Now, as we know that regression are those types of models in which independent and dependent variable are following a linear pattern. And in simple linear regression, we were having just one independent variable and one dependent variable, but in multiple linear regression we'll have multiple independent variable and one dependent variable. That is, multiple independent variable will be plotted on one axis and our dependent variable, which is our output, will be plotted on the other axis. So let's see the formula. Now in this formula there will be only one change. This slope and the independent value will be added multiple times. Let's say that you are having 3 independent values. So what will happen is this will be added 3 times. This will become b2 into x2, and this will become b1 into x2 and b1 into x3. Okay, so we'll include all the independent variables here. If you want to know that what are all these values and what is this formula, then go and see our simple linear regression videos. Okay, so, and one more thing, if you are having some categorical data in your data set and you are creating them into dummy columns, then you have to exclude the last one. That is, if you are having 3 let's say categories and you have created 3 dummy columns, then you have to just include 2 here. That is, you have x2 and x3. You don't have to include the last column, or you have to exclude at least one column to make your model work efficiently. Okay, so let's move ahead. This I have already explained in my previous video, and this also, that what is best fitting line and everything. The only difference is that we are having multiple independent variables here, and this is the change in the formula which will happen. Okay, so let's get straight to our programming and let's see what we have to do. And let's first start away okay, so let's first start away with importing our libraries. Okay, so now let's see our data set. So let me move to our multiple linear regression. Okay, so this is our data set. And let me explain you all these columns here. Okay, so let's put this with our data set, and x1 is the death rate per 1000 residents, x2 is the doctors available per 100,000 residents, x3 is the hospital availability per 100,000 resident, x4 is the annual per cost income in thousands of dollars, x5 is the x5 is population density of people per square mile. So x1 is our dependent variable, that is the death rate per 1000 residents, and x2, x3, x4, s5 are our independent variable. Okay, and the courtesy for this dataset goes to the Life in American Small Cities by G.S. Thomas. Okay, so let's start working on our dataset, and let me go back to our notebook and let's load our dataset with the variable data set. Okay, so now we have loaded our data set. Let's see how it's looking. Okay, so there we go. Now let's create our x and y variable for our independent and dependent columns, where x is our independent variables and y is our dependent or output. Now let's see how our x and y variable is looking. Okay, so x is having all the independent values here, and let's see that how many values are present in our x data set, and there you can see 53 values. Now let's train okay, so now let's split our data set into test and train, and as we have seen, our data set, it is not having any missing value, so we are not doing that part of data pre-processing. Neither our data set is having any categorical value, and we don't need to do feature scaling for our this multilinear regression model. Okay, so we'll straight away move to splitting of our data set. So I'll once again copy and paste the code because I don't want to waste time in writing when I have already written the code before. So I'll just copy and paste here, and I'll focus more on explaining you how things work. Okay, so if you want to know how this test and train is working, I have created a dedicated video for that. You can watch that. I'll provide the link in the description for each of my video, and our model is training and it's taking a bit of time. Okay, so let's give. Okay, so it's trained here. Now let's see how our x just a second. Let's see how our x train and x test data is looking. Okay, so we have splitted this into 20%, so obviously this will be having just 11 values. Okay, and same for the y test also, and our train value is having 42. Okay, so now let's do the main work, that is called the sklearn linear regression package, so that we can do our multiple linear regression. Okay, so let's get here and copy. Okay, so we have imported our library, and then we'll create a class variable here. Regressor is equal to linear regression, and this is same as simple linear regression because the class is same, and we the only difference that we were having from simple linear regression was the presence of a single independent variable. In this we are having multiple. Okay, so let's run this, and now let's train our model. So what we are doing here is we are providing our model, which is this class object here, with our x train and x train and y train, so that our model learns from our training data and understand the pattern that our data set is following. Now let me call this dot predict. Let's save this into a variable. Let's say pred dot predict, and let's provide our x test value here. Okay, so now let's see what are the values stored in our pred variable, and we'll compare this with our y test so that we can see that what is the accuracy of our data set. There you can see 10, 8.3, not that accurate, 9.6, 9.8, pretty close, 8, 7.3, not that close, 10. Oh, okay, so you can compare this value. I don't need to do anything here. Okay, so this is it for this video. This was a very simple video, and multiple linear regression isn't that different from simple linear regression. The only difference was that it was having multiple columns for our independent variable. Now you have to look very closely to the data set when deciding that what are the independent and dependent variable and what factors can actually affect your output, because this data was pretty obvious. There you can see, where is our data set? There you can see that in this data set the values were pretty obvious that all the factors will affect the death rate, but in some data set there are some useless columns, so you don't want to include them. So you have to read the data set very accurately to decide that what will be the model used and what will be the column for our independent and dependent variable. Okay, so this is it for this video. In the next video we'll see how the polynomial regression model works. Okay, so meet you there. Bye bye.